We are now ready to start writing some code, and over here I have created an empty project and I've already included the pubspec.yaml file that we have used in the previous section, so that we can run our code with null safety enabled. So if you want, you can grab this file from the previous section, or you can download the pubspec.yaml file that I've attached in the resources for this lesson. So in our terminal, we can type pub get to get all the dependencies. And then we can create a new file called checkout.dart. And the first thing that we want to do is to add a new product class. So here we can type class product, and inside it we can declare a final int ID and a final string name and a final double price. Then we can add a constructor and make this required named arguments, and also make this a const constructor. Then let's create an item class that will represent a product along with a quantity. So here we can type class item, and then we can add a final product and a final int quantity. And we can also add a constructor for this. And this can be a const constructor, and as usual we can use named arguments and make the product argument required. And in this case, I feel it's appropriate to use a default value of 1 for the quantity, because that's what the user will choose by default when selecting a new item. In addition to this, it would also be nice to have a getter variable that can tell us what is the price for this item. So here we can type double get price and use the arrow notation to return quantity times product.price. Finally, we can add a class to represent our cart. So let's do this. And this can be a class cart. And this cart should contain all the items that the user can add using the interactive prompt. And since we need multiple items, then this should be a collection. But what kind of collection is it? Is it a list, a set, or a map? This is not entirely clear at this stage, because we haven't decided how we are going to add items to this cart. So what I suggest we do is to leave a to-do for now and come back to this later. And now we can start building our interactive prompt so that we will have a better idea about how to implement this cart. So let's continue on the next lesson. Now that we started fleshing out the classes that we need, we can start working on the interactive prompt. And just like we have done in the previous project, I think it's a good idea to write some pseudocode so that we have a clear direction of where we are going. So we can start with an infinite loop, and inside it we can prompt the user with one of these options. And then if the selection is add item, then we can choose a product and add it to the cart, and also print the cart. Otherwise, if the selection is view cart, then we just print the cart. Otherwise, if the selection is checkout, then we do the checkout and we exit the application. And this closes the loop. Next, we can add our void main method, and then we can add a while true loop. And inside it, we can add our prompt and type standardout.write. And in order to use standardout, we need to import dart.io. Then let's show a message to the user. So here we can add a string literal with the text, what do you want to do? View items, add item, or checkout, like this. So by typing V, A, or C, the user will be able to select one of these options. And to read this selection, we can type final line equals standard input dot read line sync. And then we can add a chain of if-else statements to check which option was selected. So we can type if line equals to A, and then inside it we can add a to-do so that we can implement this later, else if line equals V, and we can add a to-do in here as well, else if line equals C, and we can add a to-do in here as well. And our next goal is to replace these to-dos with some actual code. And if the user has chosen to add an item to the cart, then we need to present a list of available products to choose from. But we haven't created that list just yet. So let's do this. And over here, above the main method, we're going to define it as a constant global variable. So here we can type const all products equals to a list literal that contains a product with ID equals 1, name equals apples, and price 1.60, for example. And then we can add a few more products. So feel free to pause the video and copy them by hand. Next, let's figure out how to make the user choose one of these products. And for this, I suggest that we create a separate function. This can be a product choose product. And we are making this a nullable return type so that we can return null if we can't find the product that the user is looking for. Then inside here, we want to print the full list of items along with their price. And if we wanted, we could add the string formatting logic that we want inside this function. But I think it's a better idea to add this inside the product class. So let's go back to the top. And here we can add a string get display name. And we can use the arrow notation to return $name. And then we can escape the dollar symbol and add $price like this. Then we can go back to the choose product function, and here we can type final products list equal to all products dot map, and then for each product we can return product dot display name and add dot join with a new line character at the end. So what this code does is to take all the display names and then add them together into a string, using a new line as a separator so that each product shows on a different line. And now that we have this, we can type standard out.write, and inside it available products, and then new line, and then $products list, and then another new line, and then your choice. And we will see how this looks like when we run the program. But for now, let's continue. And here we want to read the user input so that we know which product was selected. So here we can type final line equals standard input dot read line sync. And the next step is to compare this line with the name of each product so that we can find a match. But we don't really want the user to have to type the entire product name by hand. To show you what I mean, here is the finished project. And as you can see, here the user only has to type the initial of the product name that he or she wants. So we need to implement this behavior so that we just compare the first letter. But how can we do this? Well, what I propose we do is to add another getter variable to the product class that represents the initial letter for the product. To do this, here we can add a string get initial, and we can use the arrow notation to return name.substring with arguments 0 and 1, where 0 represents the index where the substring begins and 1 is the length of the substring. So by doing this, we are getting the first letter of the string. And now that we have done this, I think we can slightly modify the display name so that the initial shows between parentheses. To do this, we can replace $name with parentheses and $initial inside them, and then dollar with curly braces, and inside it name.substring with index 1. And this will show the initial letter within parentheses followed by the rest of the name starting from the letter at index 1. Then we can get back to our choose product function, and here we can type for var product in all products, and then inside it if product.initial is equal to line, then return product. And if we reach the end of the loop without finding a matching product, then we can type print not found and return null. Okay, so our choose product function is complete and we can test it on the main method. So here we can remove this to do and type final product equals choose product, and if product is not null, then print product.display name. And before we add any more code, I think we are in a good place to test what we have so far. So we can save the file, open the terminal and type dart checkout.dart. And if we run this, we see that we get the initial selection prompt. And if we press A, then we get a list of products. And if we choose X, which doesn't match any of these initials, then we get not found. And we are back to the initial prompt. And if we select A again, and this time we can press B for banana, then we can see that bananas is printed, and this means that a product was found. So let's continue on the next lesson where we will see how to add items to our cart. Now that we know how to select a product from the product list, we need to figure out how to add it to our cart. So let's move over to the cart class, and here we can add a void add product method with a product argument. And now we need to decide how to implement this. And we need to consider two possible cases. the product was never added to the cart, and so we need to create an item with quantity equals 1, or the cart already contains an item with that product, and in that case we want to increment the quantity of that item by 1. But how can we check if an item is already in the cart? Well, when we have created our product list, we have assigned different unique IDs to each product, and we could use this ID to identify the items inside our cart. So here we can remove this to do, and what I propose we do is to create a final map with keys of type int and values of type item, and we can call this _items to make it private, and we can initialize it to an empty map. Then inside the add product method, we can type final item equals to items of product.id, and then if item is equal to null, then items of product.id equal to a new item with product of product and quantity 1. Else, items of product.id is an item with product, and for the quantity argument, we can pass item.quantity plus 1. So the way this code works is that first we check if we have an item with a given product ID, and then we assign a new item either with a quantity or 1 or the previous quantity plus 1. And note how when we do this, we are not mutating the state of the existing item, and instead we are assigning a new item altogether. As a result, the item class can be immutable and the quantity can be a final variable. So the only thing that changes are the keys and values of this map. And now that we know how to add items to the cart, it would be nice to override the toString method so that we can get a nice string representation of all the contents in the cart. And we will use this when the user chooses to view the cart from the interactive prompt. So let's override the toString method. And here we can remove this generated code, and we can start with a defensive check that says if items.isEmpty, then return cart is empty. And then we would like to print all the items along with their quantity and price. To help us with that, we should implement the toString method in the item class as well. So let's do this, and we can type toString, and then we can replace this body with a string literal that contains $quantity times, and then string interpolation with product.name, and then we can add the dollar symbol and then $price. Then we can go back to the cart toString method, and here we can type final itemized list equals to items.values.map, and then for each item we can return item.toString, and then we can join all these values with a new line separator. Now here we could return this variable directly, but it is also important to see the total value in the cart. So let's add a new method to calculate this, and here we can type double total, and this would return items.values and then .map, and for each item we want to return item.price, and then we can call reduce, and here we get a value and an element, and we can return value plus element. So what this code does is to get all the item prices using the map operator, and then combines them with the reduce operator to get the total. And now that we have this, we can complete the toString method. So here we can return a string literal that contains $itemized list, and then a new line, and then total, and then we can escape the dollar symbol, and then within string interpolation, we can call the total method. And now that this is complete, we can get back to our main method. And outside the while loop, we can add a final cart equals cart. And then inside the if statement, we can replace this print method with cart.addProduct, and we can print the cart. And if the user chooses to view the cart, we can also print it here. And now that this is done, we can save and run the program once again. And as we can see, when we add an item, this will show the contents of our cart. And as we add more items, then the cart is updated. And before we continue, I'd like to do a small tweak and add a separator when we print the contents of the cart. So let's get back to the toString method inside the cart, and here we can add 6 dashes followed by a new line before the itemized list, and also a new line followed by 6 dashes at the end. And then we can open the terminal again and interrupt the previous program, and then we can run it again. And now we can see that when we add items, then we get this nice separator when we print the cart. And we can also type V on the interactive prompt to view the cart again. So this completes all the functionality that we need to add items to the cart. So let's continue on the next lesson. In this lesson, we are going to complete our simple e-commerce application, and the only thing that is left to do is to add the functionality to do the checkout. So let's create a new function that we can use to implement this. This function will return a Boolean variable that will tell us if this checkout was successful or not. And we can call this checkout and give it a cart argument. And the first thing that we want to do is to add a check to see if the cart is empty, because if that's the case, then we have nothing to do. Now, when we created the cart class, we said that the items variable is private and we are not really supposed to use it outside the cart class. So what we can do instead is to add a new bool getter variable called isEmpty, and we can use this to return items.isEmpty. So by doing this, we are exposing a way to check if the cart is empty while keeping the items variable private. And now that we have this, we can go back to the checkout method and we can type if cart.isEmpty, then we can print cart is empty and we can return false. Next, we want to print the total so that the user knows how much he or she needs to pay. So here we can type final total equals cart.total and then print total. And here we can escape the dollar symbol and use total with string interpolation. And since this is not a fancy e-commerce website and we want customers to pay in cash, we can type standardout.write and inside it payment in cash. And then final line equals standard input.readLineSync. So this is how we read how much the user has paid. And here we can add a defensive check and type if line equals null or line is empty, then we can return false. And if this line is not null or empty, then we can try to parse it into a double number. So here we can type final paid equals double.try parse with line. And what this method will do is to try to convert a string into a double number. But if this is not a valid number, it will return null. So let's add another check that says if paid equal null, then return false. Finally, we can check if the user has paid the correct amount. So here we can type if paid greater or equal than total, then final change equals paid minus total. And then we can print the change and then we can escape the dollar symbol and then use string interpolation to print change.toString as fixed with 2 decimal digits. And in this case, we can return true. Otherwise, we can print not enough cash and we can return false. So this last check makes sure that the user pays enough money for the purchase and gets the right change. And this completes the functionality for our checkout method. And now we can get back to our main method, and here we can replace this to do with if checkout and we can pass cart as the argument. And if this condition is true, we can add a break statement that takes us out of the while loop. And this completes our program. So let's save this file and test our app one more time. So here we can run it. And first of all, we can add an item to the cart, for example, P for potatoes. And then we can type C for checkout. And if we enter an empty string, then nothing happens and we return to the previous prompt. If we try to check out again and type something that is not a number, we also return to the previous prompt. And if we try again and enter an amount that is smaller than the total, then the program prints not enough cash. And finally, if we enter an amount that is greater than the total, then we get the correct change and our program completes. So this is a good example of how to code defensively and handle errors gracefully. And this completes the implementation for our simple e-commerce application. So let's continue on the next lesson, where I want to talk about project structure and do a wrap-up. Now that our commerce application is complete, it's a good time to talk about project structure. You see, up until now, we have added all the code for this project inside a single file called checkout.dart. And this is a relatively small application that doesn't have many lines of code. But as your projects grow bigger, it's not a good idea to keep all your code in one file. So what I propose we do is that we break this into multiple files. And rather than keeping all the files in the root of our project, it's a better idea to create a folder called lib. And inside here, we can create a new file called product.dart. Then we can get back to our checkout.dart file. And here we can select this product class, and then we can cut this code and paste it in here. Similarly, we could create another file called item.dart. And then we can select all the code for the item class, and then we can cut it and paste it in here. And as you can see, here we get some errors because product is not defined in this file. To fix this, we can select this code, and if we use the magic wand, we can choose to import product.dart like this, or using the test package as a prefix. And as long as all your files live in the same package, then it doesn't really matter which one you choose. So here I'm just going to import product.dart. So let's save this, and now we have just one class to go. So here we can create a new file called cart.dart, and we can repeat the same process by taking all this code from here and we can paste it in here. And once again, we need to import item.dart and product.dart because they are both dependencies for this file. So let's save this, and finally we have this checkout file to deal with. Now, this is the file that contains the main method, which is the entry point for our application. And by convention, the file that contains the entry point should be called main.dart and live inside a folder called bin. So let's create a new folder called bin, and then we can rename this file to main, and then we can move it inside that folder. And finally, we can use the magic wand to import the files that we need. And as we can see, the only option that we have is to import this file from the test package, which now contains all the files that we placed inside lib. Then we can scroll down and we can also import cart.dart from the test package. Then we can save this file, and as we can see, the product and cart imports appear at the top. And now that we have done all of this, we can open the terminal and run the program by typing dart bin/main.dart, because this is the new location of the main method. And here we can use our interactive prompt as usual. So in general, it's a good idea to break your source code in smaller files. And in this case, we have decided to add a new file inside the lib folder for each class that we have created. And we have placed the main file inside the bin folder. And now our project is complete. In summary, we have now created a relatively simple commerce application that we can use to manage a product list, add items to the cart, and check out when we have completed our shopping. And I feel this was a good way to apply the things that we have learned about classes. So I hope that you have enjoyed this project, and we can continue on the next section. In this section, we are going to talk about mixins and extensions, which are two features of the Dart language that make it easier to extend the functionality of existing types. And as we have seen before, in Dart, classes can only extend a single class. In this context, mixins are quite useful because they allow you to overcome this limitation and increase code reuse in your class hierarchies. And we will see some examples of this. On the other hand, extensions solve a similar problem but from a different angle, because extensions are also a way to add functionality to existing classes, but they can do so without having to modify the original class. And this makes them well suited for extending classes that belong to the Dart SDK, as well as code that lives inside separate packages or libraries. Before we write any code, we need to set up a project and enable null safety, just like we have done in the previous sections. So over here, I started a new project and I've added the same pubspec.yaml and analysisoptions.yaml files that we have used before. So feel free to import them from the previous project, or download and extract the zip file that I have attached in the resources for this lesson. And once you have done this, you should have a new project with just these two files. And you can type pub-get on the terminal to install all the required packages. So let's get started and learn about mixins and extensions. In this lesson, we will learn how to create and use mixins. To start off, we can create a new file called mixins.dart. And as an example, suppose that we have this simple class hierarchy. We can have a class animal, which is empty, and then we can create a class fish, which extends animal, like this, and also a class human, which extends animal, like this. Now, there are things that all animals do, for example, breeding. So if we were to add a void breed method that prints breeding to the animal class, then both fish and humans will be able to breed. And there are also other skills that both fish and humans share, for example, the ability to swim. However, not all animals can swim. So if we wanted, we could add a void swim method that prints swimming to the fish class, and then we can copy this method and paste it inside the human class, because humans can swim as well. But as we can see, we now have some code duplication because we had to implement the same swim method in both classes. And the solution to this is not to move the swim method to the animal class, because it's definitely not true that all animals can swim. And also, it doesn't seem right to add another superclass that is shared by both the fish and human classes, so that they can both swim. So this is an example where mixins come handy, because we can add a mixin swimming, like this, and then we can move this swim method from the fish class to the mixin, and we can also remove it from here. And then we can update these class declarations and have class fish extends animal with swimming, and class human extends animal with swimming. And as we can see, we no longer have any code duplication. And in order to accomplish this, we didn't have to change the original class hierarchy in any way. And as a proof that this works, here we can add a void main method, and then we can type final fish equals fish and fish.swim, and we can also create a final human equals human and say human.swim. So mixins give us a convenient way of sharing functionality between multiple classes in a flexible way. So if we wanted to take this example a little bit further, here we could define a mixin called mixin breeding, and then we could take the breed method from the animal class and move it in here. And here we can update this and say class animal with breeding. And now that we have this mixin, we can easily define a class plant with breeding, like this. And plants can also breed, so they can reuse the same breeding mixin as the animal class. And the important thing to notice is that by structuring things this way, we are defining a set of behaviors using mixins rather than hard coding these behaviors inside classes themselves. And this leads to code that is easier to maintain. The other benefit of using mixins this way is that it leads to more shallow class hierarchies. Instead, if we don't use mixins and we can only rely on single inheritance, then we are more likely to end up with deep class hierarchies, which are harder to maintain. By the way, up until now, we have created mixins using the mixin keyword. However, if we wanted, we could have used the class keyword instead. And this is possible because in Dart, any class can be added as a mixin to another class. So what is the difference between declaring a mixin with mixin or class? Well, let's go to the main method and delete all this code. And here we can create an instance of type breeding, because breeding is a class. However, we can't type final swimming equals swimming because mixins can't be instantiated. So the takeaway here is that we cannot create instances of types declared as a mixin. And in fact, both swimming and breeding are verbs that represent some actions, and it doesn't make sense to create an instance of type breeding because this is not a noun and it's a verb that represents an action or behavior. So I think it's more appropriate to declare breeding as a mixin, and as a result, we can't instantiate it. Okay, so let's comment out this code and we can continue on the next lesson. In the last lesson, we have learned about mixins and their advantages, and because we can use them to extend the functionality of existing classes without subclassing, you may think that mixins are amazing and try to use them everywhere. Well, not so fast, because mixins also have some drawbacks. Mixins can't have constructors. And this makes sense because we have seen that we can't instantiate objects of a mixin type. In fact, the whole point of a mixin is to mix it into other classes. And another important drawback is that mixins can lead to name collisions because we can define member variables or methods with the same name inside two separate mixins, and this can make things quite confusing. To show you what I mean, here we can create a new file called mixins2.dart. And inside here, we can type mixin1, and inside it, we can declare an int foo variable equals 1, and then another mixin called mixin2, and this would also define an int foo variable, but with a value of 2. Then we could declare a class foo with mixin1, mixin2, and inside it, we could add a void print foo method that prints foo, like this. And this is valid syntax, even though both mixins have a variable called foo. But which foo variable is actually used when we call this method? To find out, we can add a void main method, and then we can declare a final foo equals foo, and then we can call foo.print foo. And if we run this code, we can see that the output is 2, which means that we are accessing the foo variable inside mixin2. But it also means that we can't access the foo variable inside mixin1 from this class. So in general, it's not a good idea to create mixins that can lead to name collisions like we have done in this case. And if you work on bigger projects that have a lot of mixins, it may be hard to find out that you have a name collision because the compiler doesn't warn you about this. So as you write your own programs, should you use abstract classes and interfaces or mixins? And the answer is that it depends on your specific use case, and you should consider the advantages and disadvantages of using mixins when you're trying to decide. So this completes our overview about mixins, and we can continue on the next lesson. In this lesson, we are going to learn about extensions, which are a way to add functionality to existing types. Extensions are quite easy to use, so let me show you a practical example. First of all, let's create a new file called extensions.dart, and inside it we can create a void main method. And as we know, if we want to parse a string into an integer, we can type something like this: int.tryParse with a string literal, for example 1, 2, 3. However, this syntax doesn't read very well in English, and instead it would be nice if we could type something like 1, 2, 3 inside single quotes, and then 2 int or null. And this would convert this string to an integer if this is a valid number, or return null otherwise. But of course, the string class doesn't have a method called toInt or null. So this is where extensions come handy, because we can write extension on string, and inside it we can declare a method that returns a nullable integer value, and we can call this toInt or null, and we can use it to return int.tryParse, and we can pass this as an argument. And the reason we use this here is that we are inside an extension of string, so this will be the string value itself, and we can try to parse it using int.tryParse. And now that we have this, we can see that this code is valid. And one of the great benefits of extensions is that it makes autocomplete easier, because here we could type a string literal with the value 456, and if we press dot, we can see that toInt or null is already available inside the list of options. So extensions are quite useful, and because of this, you normally want to keep them in separate files so that you can import them in multiple places. So if we wanted to make this extension reusable, we could create a new file called numberparsing.dart, and then we could move this extension from here to here and save this file. And then back in the other file, we can see that we have some errors saying that the method toInt or null is not defined. So here we can import number parsing.dart, but as we can see, the errors don't go away. And that's because when we import extensions, we can only use them if they have a name. In other words, here we can say that this extension is called number parsing. And now that it has a name, we can go back to this other file, and as we can see, the code now compiles. So the takeaway is that if you want to reuse your extensions across multiple files, make sure to give them a name, like this. Okay, so let's continue on the next lesson. In this lesson, I'm going to show you an interesting use case for extensions using generics. So we can create a new file called iterable_sum.dart, and we can add an empty main method inside it. And suppose that we want to add a new method to the list class so that we can calculate the sum of all the items inside the list. In other words, here we would like to type final sum equals a list literal that contains the values 1, 2, and 3, and then dot sum. But this is not a method inside the list or iterable class. So in order to make this work, we need to add an extension, which we could call iterablex on iterable of type int. And then inside it, we could create a function that returns an int. We would call this sum. And as we know, we can calculate this with the reduce method and use the value and element values to return value plus element in the combine function. And now that we implemented this, we can see that this code is valid. And if we print sum and run this program, we can see that the output is 6. However, if we change all these values to be doubles, then we can no longer use this extension because this only works on iterables of type int. But I'd like to remind you that both int and double are subclasses of num, which is a class that we use to represent numbers in Dart. So if we want, we can update this extension to work on all instances of type num. And to do this, we can change this type to num. And we can also update the return type of this function. And now that we have done this, in our main method, we can type final sum1 equals list literal with values 1, 2, and 3 dot sum. So this is great because our code now works both with lists of type int and lists of type double. But there is still a problem because the return type of this expression is num, and that means that we can't assign this to a variable of type int or double. And in fact, this error is telling us that a value of type num can't be assigned to a variable of type int. And in order to solve this, we need to use a so-called generic type constraint. So this is how it works. After the extension name, we can add some angular brackets. And inside here, we can type t extends num, like this. And then we can use t as the type of this iterable and also t as the return value. And because Dart is not smart enough to work out that this expression is also of type t, we can surround it with parentheses and add as t after it. And now that we have done this, the return type of this expression will match the type of the values inside the list. And this means that this code is valid. In summary, if you create an extension and you want it to apply to all subclasses of a specific class, you can use a generic type constraint on that class. And to do this, you need to type t extends followed by the name of the base class. And if you don't specify a base class explicitly, then Dart will use object by default, meaning that the extension will be valid on any type because all classes are subclasses of object. So type constraints are a way to restrict an extension or class to only subclasses of a certain base class. So this completes our overview of extensions in Dart. And I should mention that there is a package called DartX that offers a lot of useful extensions that you can use when you work with iterables, as well as strings and time objects and a lot more. So I recommend that you get familiar with this package because it can save you some time in your own projects, and also you can explore its source code and learn more about interesting ways of using extensions. Okay, so let's continue on the next lesson where we'll do an exercise. It's now time for a new exercise. So given the following incomplete program, which should print all the integers from 1 to 5, I'd like you to create an extension on int that implements a range2 method. This method should take an int other argument and use it to return a list containing all the integer values inside the range in increasing order. And if the other argument is less than the initial value, then the method should return an empty list. So you can go ahead and try to solve this by yourself, and then I'll show you the solution. Okay, so let's do this together. So first of all, we can create an extension range on int, and then inside it, we can add a method that returns a list of type int, and we can call this range2 and give it an int other argument. Then we can add a defensive check that says if other is less than this, which is the current value, then we can return an empty list. And then we can initialize a list variable that contains the current value. And then we can add a for loop where we initialize a counter variable to this +1, and we can continue until I is less than or equal to other, and we increment at each iteration. Then inside the loop, we can type list.add with I, and at the end, we can just return list like this. And now that we completed this extension, we can run this code and we can see that the output contains the values 1 to 5. And if we change this argument to 0 and we run again, then this time there is no output, and this confirms that this method has returned an empty list. So this completes this section about mixins and extensions. And alongside this, in the previous sections, we have also covered classes, abstract classes, interfaces, inheritance, and composition. And this means that you can now write your own programs using object-oriented programming principles, using all these different language features. And I believe this knowledge will be immensely useful as you progress in your programming journey. So let's continue on the next section. In this section, we are going to talk about error handling and exceptions. Whether you're building a mobile app, a website, or a command line application, it's important that your code is robust so that it can deal with any error conditions that may arise. And depending on what your programs or apps do, there are many different kinds of errors that may occur. For example, if you read or write data to files in your local file system, then you need to handle I/O errors. Or if you're making a network request and it can't be fulfilled, then you should handle networking errors. In addition to this, there are also errors that are caused entirely by yourself, and these are known as programmer errors. So in this section, we will learn about the difference between errors and exceptions, and we will see how to handle them in Dart. As part of this, we will talk about assertions and see what kinds of errors and exceptions are available in the Dart SDK. We will see how to throw exceptions when something goes wrong, and how to use try, catch, and finally to handle them, so that by the end of this section, you'll be better equipped to build robust programs that can handle errors gracefully. And this knowledge will be very valuable in the next section, where we will learn about asynchronous programming. Okay, so let's get started. When something goes wrong in our programs, we often say that an exception or an error has occurred. These two words are often used interchangeably, but they actually have different meanings and they apply to different cases. So before we do anything else, let me clarify what is the difference between exceptions and errors. An error is a programmer mistake telling us that we did something wrong, and it is our job to address it by fixing our code. Examples of programmer errors include things like calling a function with invalid arguments or trying to access a list with an index out of bounds. Instead, an exception is a failure condition telling us that something unexpected happened. By unexpected, I mean something that is out of our control, and the way we deal with programmer errors is very different from the way we deal with exceptions. Quite often, when an error occurs, our program should terminate immediately because it is not safe to recover from it. On the other hand, when an exception occurs, we should catch it and present a human-readable message to let the user know that something went wrong. And when an exception happens, our program or app should be able to resume normally. And now that we know the main difference between errors and exceptions, let's see how we can use them in practice. So over here I have a new project, and as usual I've added the pubspec.yaml file so that we can enable null safety. So make sure to also use this file, and you can grab it from the resources in this lesson if needed. And then I can run pub get, and after the dependencies are installed, we can continue to the next lesson. In this lesson, we are going to learn about assertions, and to do this, we can create a new file called assert.dart. And then we can create a new class that we can use to represent a positive integer number. So here we can type class positive int, and then inside it, we can declare a final int value. And then we can add a constructor, and we can make it a const constructor. And when we use this class, we want our program to terminate if we try to create an instance with a negative value. To do this, we can use an initializer list, and here we can type assert and then value greater than or equal to 0. And then we can add a main method, and here we can type final invalid age equals positive int and pass -1 as the value, and then we can print invalid age. And if we open the debug console and try to run this program, we can see that we get an unhandled exception along with an error message and some information about where the error took place. So this is a good example of a programmer error because it is a mistake to pass a negative argument to this constructor. Now, this assertion is quite clear because we can read that value greater than or equal to 0 is not true. But if we want, we can add our own custom message to this assertion. To do this, we can add a comma and a string literal, and inside it we could type something like value cannot be negative. And if we run this code again, we can see that the assertion message has changed. So we can use assertion messages to provide a clear explanation of what went wrong, and this can be quite useful to other developers. By the way, since we have declared this class with a const constructor, here we can replace final with const. And as we can see, Dart now produces a compile time error because it can determine at compile time that we are passing an invalid value. So this is another advantage of creating compile time constants because we can spot assertion errors before we even run the program. So let me comment out this code, and next let me point out that you can use assertions anywhere in your code and not just inside a class constructor. For example, here we could create a void sign-in method which takes a string email and a string password argument, and then inside it we could add two assertions that say assert email dot is not empty and assert password dot is not empty. And then in our main method we can call sign in with an empty email and an empty password. And if we run this, we can see that our program is interrupted. So assertions can be quite useful because they help us catch programmer errors early. And what's great about them is that they contain a so-called stack trace, which shows us all the functions that we're currently executing when the error occurred. These contain references to code that belongs to our project, as well as code that lives inside the Dart SDK or any other third-party packages that we are using. And the stack trace is very useful because we can click on these links and they take us exactly to the line of code where the error took place. And if you're working on a big project with a lot of files, you can use this to locate the place where things went wrong and you can fix your code. So the takeaway here is that assertions make it easier to diagnose and fix any programming errors in your code. So you can create your own assertions and you can use the stack trace to figure out where things went wrong in your code. In any case, when you call methods in the Dart or Flutter SDK and you pass invalid arguments, then you will also get an exception. For example, here we could create a const list equals to a list literal with the values 1, 2, 3, and then we could print list at index 4, which is out of bounds. And if we run this code, then this time we get a range error telling us what we did wrong. And once again, if we click on this link, we are taken to the line of code where we made our mistake. So my advice is that whenever you get an error in your code, the first thing you need to do is to look at the stack trace and locate the line that caused the error. And from there, you should be able to work out what you did wrong and how to fix it. By the way, all the various errors that we have encountered in this lesson are subclasses of a class called error. So if you type this in your code and you command click on it, you'll be taken to a file called errors.dart, which lives inside the Dart SDK. And here you can spend some time learning about all the subclasses of the error class and learn about their purpose. So take the time to read the documentation and you'll have a better understanding of how things work under the hood. Before we continue, I want to mention one last thing, and that is that if you are building a Flutter app and you are running it in debug mode, then all assertions are enabled. But when you compile the app in release mode so that you can ship it in production, then assertions are disabled. And that's because assertions are only a safety net that you should use to fix programmer errors early before you ship your apps in production. On the other hand, exceptions can be triggered both in debug and release mode. So let's continue on the next lesson where we will learn about exceptions. In this lesson, we are going to learn about exceptions. Exceptions are common in a number of different scenarios, such as when we are dealing with network requests or file I/O, and in general any kind of operation that can fail unexpectedly. And unlike with errors, we should be able to recover when an exception happens, and Dart comes with some language features that we can use to do this. So let's see how exceptions work in practice with an example. To start off, we can create a new file called exceptions.dart. And here we are going to create a new class that we can use to represent a fraction. So let's type class fraction, and we can add a final int numerator and a final int denominator. Then we can add a constructor and move it to the top. And then we can add a double get value and use this to return numerator divided by denominator. And finally, we can create a void main method, and inside it we can declare a final f equals to a fraction with values 3 and 5, and we can print f.value. And if we run this, we get 0.6 on the console. Now, one thing that we should be careful about is that when we use fraction, it is invalid to use 0 as the denominator. In fact, we can update this value to 0, and if we run our program, we can see that the output is infinity. But let's suppose that we don't want this, and instead we would like to throw an exception if we try to create a fraction like this. To handle this, we can add a constructor body and type if denominator is equal to 0, then throw an integer division by 0 exception. And this is a specific kind of exception that is available in the Dart SDK. And now that we added this, we can run our code again. And when we do this, we get an unhandled exception with this type along with a stack trace, and our program is interrupted. But since this is an exception that was thrown in our code, we can actually recover from it. And to do this, we can surround our code with a try block, which looks like this. And then we can add a catch block, which gives us an argument that contains the exception that was thrown. So what we can do with this is to print e. And if we run the code now, we can see that we still get an integer division by 0 exception, but we no longer interrupt the program. As a proof of this, here we can create a new void test fraction function, and then we can move all this code from the main method into this function. And then we can call test fraction from here and add another line that says print done. And if we run this, we can see that done is printed after the integer division by 0 exception. So on one hand, we can throw exceptions using the throw keyword, and on the other hand, we can catch them using the try catch blocks. And you may be wondering, what is the point of using throw in our code if we are going to catch the exception anyway? In fact, if this denominator was a variable, we could just use an if statement to check that it is not 0 before creating a fraction object. And the answer is that using throw, try, and catch makes it explicit that we are handling some unexpected exception. And when we use catch, we can also specify a second argument that represents the stack trace. And this carries a lot of useful information about where the exception happened. Not only that, but in Dart we can use multiple catch statements to check for different kinds of exceptions. And to do this, here we can type on integer division by 0 exception, and when we do this, this code will only execute if the exception was of this type. And if we want, we can add another catch and type on exception catch e. And also we could print e, for example. And this can be quite useful if we want to respond to different kinds of exceptions in different ways. Not only that, but we can also add a special keyword called finally at the end of this block of code. So we can use this to execute some code regardless of whether there was an exception or not. As a proof of this, here we could type print test fraction done. And if we run the program now, we can see that the output contains this exception as well as the output from this print statement and the output from this print statement in the main method. But because we've run this code with a denominator of 0, then this printf.value statement is not executed because this code throws an exception. And instead, this catch block is executed because the exception type matches, and after that the finally block is executed. On the other hand, if we change this denominator to 5 and then run again, we can see that we print this value followed by the code in the finally block, and then we get this line from the main method. So this is how try, catch, and finally work. But there is also another keyword called rethrow, and we can use it inside a catch block like this. So if we set the denominator to 0 again and run this code, we can see that the output prints integer division by 0 exception, which is printed by this line. And then we get test fraction done, which comes from the finally block. And then we get an unhandled exception. And that's because here we are rethrowing the exception after processing it. And because the main method is not catching any exceptions, then the program execution is interrupted. So rethrow is useful whenever you want to do some exception handling inside a function or method, but you still want the exception to propagate to the calling function, where you may do some further handling. In summary, in this lesson, we have seen how to throw an exception inside our code and how we can use try and catch to handle exceptions. We have learned about the on clause to catch different kinds of exceptions, and we have seen that we can use finally to run some code regardless of whether an exception has occurred, and rethrow if we want to propagate an exception higher up in the call stack. By the way, in this video we have only seen how to deal with a specific kind of exception called integer division 0 exception, and if we reveal the documentation, we can see that this implements exception, which is an interface that should be implemented by all exception types. In fact, we can create our own custom exception types by implementing exception, or if we want, we can use any of the existing exception types. To do this, we can get back to our code, and over here, if we try to type throw exception, then we get a long list of exception types which are appropriate for various use cases. And in addition to this, third-party packages often define their own exception types, and you should always read the documentation of the code that you use to find out if you need to handle any exceptions. Unfortunately, in Dart, there isn't a way to tell if a function throws an exception or not just by looking at the function declaration. So looking at the documentation is the only way to find out. In any case, we will get some more practice working with exceptions in the next sections. For now, we can continue on the next lesson where we will do an exercise. In this exercise, I'd like you to implement a simple email address class that takes an email string as a constructor argument. This class should throw a format exception if it is initialized with an empty email or the email doesn't contain the @ character. Then you should test this class with the following code that tries to create 3 separate instances of the email address class. And when you run this code, you should get these 2 lines on the output. And as a reminder, you can get the starter code for this exercise on GitHub. So try to solve this by yourself and then I'll show you the solution. Okay, so let's see how to do this. Over here we have the starter code, and as we can see, it doesn't compile because the email address class doesn't exist. So let's add this and type class email address, and then we can add a final string email, and we can create a constructor as well. And then inside the constructor body, we can add the email format checks. So we can type if email.isEmpty. Then we can throw a format exception and we can use email can't be empty as the message. Then we can add another check that says if not email.contains with the @symbol, then we can throw a format exception. And inside the message, we can type $email doesn't contain the @symbol. And now that we have this, we can run the program. And as we can see, the output says instance of email address and format exception example.com doesn't contain the @symbol. So this is almost the output that we want, and the only change that we need to make is to override the toString method to return the email. And if we run this code again, we can see that the correct email address is printed. So this completes our exercise, but before we continue, I'd like to clarify one thing. And that is that in this exercise, we have chosen to throw a format exception if the email format is invalid. But as we have seen before, we can also use assertions to interrupt the program execution if a precondition is not true. For example, here we could type assert email dot is not empty and assert email dot contains an @symbol. So in this scenario, is it better to use an assertion or an exception? And the answer boils down to whether we treat this as a programmer error or an exception that we should handle. So if we are building a program or app where we are asking the user to enter an email address, then this is an exception because the user could type an invalid email address, and we should handle this by asking the user for a valid email. So it doesn't make sense to have an assertion here. On the other hand, if we want to hardcode a predefined set of email addresses that should all be valid, then it makes more sense to use an assertion because the email addresses are not entered by hand by the user. So the bottom line is that you should choose assertions or throw exceptions depending on your use case. Okay, so this completes this section about error handling and exceptions. So let's continue on the next section. In this section, we are going to learn about asynchronous programming in Dart. This is an important topic because nearly all modern applications support asynchronous operations in one form or another. For example, here are some common asynchronous operations: fetching data from the network, writing to a database, or reading data from a file. And in all these cases, it's important that your app or program continues to be responsive while waiting for asynchronous operations to complete. And to deal with asynchrony in Dart, we can use the future class along with the async and await keywords. But sometimes we run asynchronous operations that can produce more than one result over time. And to deal with that, we can use streams, which are a sequence of asynchronous events that are delivered over time. Streams are often used when building reactive applications that can update their UI when new data is available. This is the case with Flutter, as well as many other modern declarative frameworks. So we will start this section by learning about futures and the await async keywords. Then we will talk about streams and how to use them, including how to create stream generators using the async star and yield keywords. We will learn about some of the methods that we can use to process and manipulate streams. We will cover all these topics with simple examples for now, and in the next section we'll put some of these concepts in practice and see how to use asynchronous programming with a new practical project. And all of this will give you a solid understanding about asynchronous programming in Dart. And because asynchronous programming is not specific to Dart, you'll also be able to carry over this knowledge when you work with different languages. Okay, so let's get started. In this lesson, we are going to learn about futures. A future represents the result of an asynchronous operation, and we can use futures to wait for an asynchronous operation to complete. For example, fetching data from the network, or writing to a database, or reading data from a file. Futures can have two states, uncompleted and completed. And we say that a future is uncompleted when it is waiting for an asynchronous operation to finish. And when this happens, the asynchronous operation returns a value or throws an error. And it is very important that we handle both cases in our code. So let's head over to VS Code so that we can start working with futures. And over here I have a new project which contains the usual pubspec.yaml file, so make sure to add this file to the project and run pub-get to get the dependencies. And then we can create a new file called futures.dart. Then we can add a void main method as usual. And suppose that we want to write some code to run a cafe. And the way this works is that a user can place an order, and when this is ready, we can say that the order is complete. To do this, here we can create a function that returns a future of type string, and we can call this fetchUserOrder. And then we want to simulate a delay of 2 seconds before the order is ready. So here we can use the arrow notation and return future.delayed. And as the first argument, we can pass a duration object and add a second named argument with a value of 2. And then we need to provide an anonymous function that will produce our result. So here we can add an empty parameter list and use the arrow notation to return cappuccino. So over here we have used future.delayed, which is a factory constructor for the future class. This works by adding a delay and then returns a result using an anonymous function. So this future produces a string value, and that's why we have used future of string as the return type. And now that we have this, let's see how we can use it in the main method. So if we want, here we can type print program started, and then we can call fetchUserOrder. And because this returns a future, then we can type .then, which is a method that gives us the result inside an anonymous function. So here we have one argument that we can call order, and we can use the arrow notation to print order is ready with $order. And if we open the console and run this program, we can see that the program has started, and after a small delay, we get order is ready cappuccino. And this confirms that our program only produces this result when the future completes. However, suppose that there was a problem and we can't fulfill the order because we are out of milk. And we can do this inside this anonymous function by replacing this string with throw exception out of milk. And if we try to run the program now, we can see that the program starts and then we get an unhandled exception. And this interrupts our program. So how can we handle this? Well, here we can add a new line and type .catchError, and this gives us an error argument, and we can use it to print error. And if we save and run the program once again, we can see that this time the exception is printed, but it no longer interrupts the program, and that's because we are using catchError. Now, before we continue, let's add a new line, and here we can print done and run the program again. And we can see that done is printed before the exception out of milk. And this is not quite the order we had in mind, because we only want to print done after the future has completed. So if we want to run some code when the future completes, regardless of whether it returned a value or threw an error, then we should use a method called whenComplete. And this gives us an anonymous function that we can use to print done. So we can now remove the old print statement, and if we run this code again, we can see that done is printed after the exception. And if we want, we can update the code inside our future so that it no longer throws an exception and it just returns cappuccino instead. And if we run the program again, we can see that things are still in the right order. In summary, we have now learned how to create a future that returns after a delay, and we have seen that we can process the result with the then method, catch any errors with the catchError method, and run some code when the future completes regardless of the result. However, this is not the recommended way of working with futures, so let's continue on the next lesson where we will talk about async and await. We are now ready to learn about async and await. And as we have seen in the previous lesson, we can use the then, catchError, and whenComplete to run some code when a future completes, either by returning a result or throwing an error. So this code works, but it's not very practical, because if we need to execute multiple futures sequentially, then it is hard to follow this flow of execution. For example, if we wanted to fetch the next order, we would have to call fetchUserOrder inside this anonymous function. And then we would have to nest the .then, catchError, and whenComplete methods inside it. And we would quickly end up with code that is hard to reason about. So async and await solved this problem by making it easy to work with futures sequentially. So let me show you what I mean. Over here, we can remove all these lines and we can just replace them with a semicolon. And then we can assign the return value of this function to a final order variable. And we can try to print the order. And if we run this code, we can see that it prints instance of future of type string. And this makes sense because this is the return type of this method. And what we are doing here is to assign a variable with an uncompleted future. So if we want to get the actual order, then we need to await for this future to complete. But as we can see, we now get an error telling us that the await expression can only be used in an async function. So if we want to use await inside a function, then we must make it an async function. And we can do this by adding async before the function body. And strictly speaking, this means that the main method is now asynchronous. And whenever you mark a function or method with async, then you should also make its return type a future. In other words, the main method should return future of type void. And now that we have this, we can run the program again. And this time we can see that after a short delay, then cappuccino is printed. So we can use await to wait for a future to complete and get its return value. But what if the future throws an exception instead? For example, here we could type throw exception out of milk. And if we run the program now, we can see that after a small delay, we get an unhandled exception. Well, to address this, we can wrap this code inside a try block, and then we can add catch e, and we can use this to print the exception. And if we run the code now, we can see that after the delay, the exception is printed like this. But there is more, because if we want, we can execute multiple futures sequentially using the wait keyword. For example, here we could copy and paste these two lines and rename this to order 2. But if we run the program again, we can see that we get just one exception, because all the lines following this call are not executed when there is an exception. On the other hand, if we return cappuccino from this function and run again, then we can see that the two orders appear one after the other in sequence. And as a reminder, we can also use finally and use this to print done. And this code will run after all the futures have completed, regardless of whether they succeeded or not. So let's do a summary of what we have learned. You can use the await keyword to wait until a future returns, and we can get the result value if it returns successfully. And if we have multiple futures, we can use await to execute them in sequence. But await is only allowed inside a synchronous function. And when we use await in combination with try and catch, we can also handle any exceptions that are thrown by a future. So async and await along with try and catch is a great way of working with futures in Dart. And I recommend that you use them instead of using then, catch, error, and when complete like we have done in the previous lesson. Okay, so let's continue on the next lesson. In the last few lessons, we have seen that we can use future.delayed to create a future that runs a computation after a delay. Future.delayed is a factory constructor for the future class, but it is not the only one. In fact, we also have future.error, future.value, future.sync, and future.microtask. Now, the only ones that you're ever likely to use in practice are future.error and future.value. So in this lesson, we are going to see how to use them. And to keep things simple, we are going to re-implement the same fetch user order function that we have created previously. So here we can add a method that returns a future of type string, and we can call this fetch user order 2. And this time we are not going to use future.delayed, but instead we can use the arrow notation and return future.value with Expresso. And we can use this constructor whenever we want to create a future that completes immediately. As a proof of this, here we could update this line and call it fetch user order 2. And if we open the debug console and run the program now, we can see that the first order is printed after 2 seconds and the second one is printed immediately after that. Next, let me show you how future.error works. And to make things simple, we can copy this line and paste it here. And then we can rename this to fetch user order 3. And then we can replace this code with future.error. and then inside it we can create an exception that says out of milk. And then we can update this line to call fetch user order 3. And if we run this now, we can see that we get an exception right after the first order. So future.delayed, future.value, and future.error are the most common kinds of futures that you're likely to use in practice. And you may be wondering, why should we even use a future if we want to return a value or throw an exception immediately? And sometimes this is useful, for example, when you are designing a future-based API, but you are not yet ready to write the final code. And in this case, you can use future.error and use an implemented error as a placeholder. And you can also use future.value or future.error when you're writing unit tests for classes that contain future-based APIs. So we are not going to talk about testing in this section, but for now, all you need to know is that future.delayed, future.error, and future.value can be useful, and we now know how they work. Okay, so let's continue on the next lesson. In this exercise, I'd like you to implement a countdown function that takes an integer called n and prints all the numbers from n to 0 with 1 second delay between each number. Then call countdown with a value of 5 inside the main method and verify that it works as intended. The program should print done after the countdown has completed, and you can use futures, async, and await as needed. So you can try to solve this by yourself, and then I'll show you the solution. Okay, so let's do this together. To start off, we can create a void countdown function and give it an integer argument called n. And then inside the function body, we can add a for loop. And then we can use a variable to count from n all the way to 0. And this variable can be decremented at each step. Then let's add some code to print the value of I after 1 second. To do this, here we can use future.delayed. And we can give it a duration argument with 1 second as the delay. And then we need to use an anonymous function, and we can use this to print I. Now, this function is not finished yet, but I'd like to show you what happens if we call it like this. So we can add a void main method, and inside it we can call countdown with a value of 5, and we can also add a print done statement at the end. And if we open the debug console and run this code, we can see that done is printed immediately, and after 1 second delay, all the other numbers are printed at once. So this is not what we want, because our goal is to have a 1 second delay between each print statement. To accomplish that, we need to add an await call in front of this future, and if we use await, then we must make this function asynchronous. And it's best to change the return type to future of void. And if we run the program now, we can see that this is enough to run the countdown with the correct delay. But done is still printed before all the numbers. And to fix this, we need to await when we call countdown of 5. And since we use await, we need to make this method async and make it return a future of type void. And if we run the code now, we can see that the countdown starts from 5 and goes all the way to 0. And done is only printed at the end. So before we continue, I want to point out that the order in which your code executes is important, and unless you await when you call functions that return a future, then things may not run in the order that you want. So make sure that you always use await when you work with futures. By the way, up until now we have only used future.delayed to simulate operations that can take some time to complete. And when we work with real-world applications, we need to use various future-based APIs to run asynchronous code. And we will get a real feel for how to work with futures in the next section, where we will build a weather app that pulls the latest weather information from a remote server. But for now, we'll carry on a little bit more with some theory and learn about streams. So let's continue on the next lesson. When we do asynchronous programming in Dart, the two most important classes are future and stream. As we have seen, a future represents a computation that doesn't complete immediately, and we can write asynchronous functions that return a future, and we can await until the result is ready. On the other hand, a stream is a sequence of asynchronous events, and you can think of a stream as an asynchronous iterable, where events are delivered over time rather than when you ask for them. Now, in Dart, there are various ways to create and add items to a stream. One way to do this is to generate a stream from an iterable. Another way is to use a stream generator, which is a function that uses the async star and yield keywords. And we can also use a so-called stream controller, which gives us more control about how we add items to the stream. So for now, we will focus on the first two techniques, and we may cover stream controllers later on. So let's start with a practical example. And over here, we can create a new file called streams.dart. Then we can add a void main method. And the first thing that we want to do is to create a stream that we can work with. And the simplest way to do this is to type final stream equals stream.fromIterable. And here we can pass a list literal that contains the values 1, 2, 3, and 4. And if we want to be strict, here we can add a type annotation to say that this stream only contains items of type int. Then suppose that we want to write a function that can calculate the sum of all the items in this stream. Now, because this stream emits values asynchronously, it's safe to say that this function should return a future of type int. And we can call this SumStream and add one argument of type stream int, and we can call it stream. Then we can mark this function as a sync and add a function body. Now, if we want to calculate the sum of all the items inside an iterable, we can use either a for loop or the reduce method. And the same thing is also true when we work with streams. So let's see how to implement this function with a for loop. And then I'll also show you how to do it with the reduce method. So over here, we can declare a var sum equals 0. And then we can add an await for loop that iterates through all the values inside the stream. And inside here, we can type sum plus equal value. And the important thing to notice here is that we are using await for. This is necessary because we are working with a stream and we need to await for each value to be available before we can use it. And since here we use await, then this function needs to be a sync and the return type needs to be a future. Okay, so let's complete this function by returning sum. And if we want to use this function, then we need to type final sum equals await and then sum stream with stream. And we can also print sum equal to $sum. And in order to use await, then we need to mark this as a sync and change the return type to future void. And if we run this program, we can see that the output is 10, which is the sum of all these values. Next, let's add a new function that also calculates the sum, but this time using the reduce method. And to do this, here we can add a new future of type int function called SumStream2. This will also take a stream of type int as an argument. And this time we don't need to type a sync because here we can just use the arrow notation and return stream.reduce. And here we can add an anonymous function that gives us the previous result and the current element. And we can use this to return previous plus element. So this syntax is identical to what we would write if we were using an iterable. But what happens under the hood is that the stream reduce method will wait for each event in the stream to become available before calling the combine function. And since this function returns a future and stream.reduce also returns a future, then we don't need a pair of await and async keywords, and we can just return this as an expression. And just to check that this works, here we can replace this call with SumStream2. And if we run the program, we can see that we still get the correct output. So let's continue on the next lesson where we will learn about a different way of generating stream values. In the last lesson, we have seen how to generate a stream from an iterable, and we have used it to calculate the sum of all the items inside the stream. Next, we need to talk about stream generators. So let me show you what a stream generator is with an example. Here we can create a function that returns a stream of type int. We can call this countStream, and this takes an int n argument that we will use to generate all the values from 1 to n. Then we can type async star like this. And in the function body, we can add a for loop that starts from I equal to 1 all the way to I equal to n, and we can increment I at each iteration. And then inside the loop, we can type yield I like this. So this syntax is a bit similar to what we use when we create functions that return a future. But the difference is that we return a stream rather than a future, and we use async star rather than async, and we use yield rather than await. And what this code lets us do is to generate multiple values and use them to create a stream. In fact, in the main method, we could create a final stream2 equals to count stream and pass a value of 4. And then we can pass this as an argument to some stream, like this. And if we run this code, we can see that it produces the same result as before. And that's because this function will generate a stream with all the values from 1 to 4, and this function will calculate the sum. Now, if we wanted, we could add a delay inside this for loop so that all the stream items are not generated at the same time. And to do this, we can type await future.delayed with a duration of 1 second. So here we are using a future to simulate a delay, but in a real-world application, here we could do some asynchronous work and await for the result. And just to show you that the stream items are generated with a delay, here we can add a print I statement. And if we reveal the console and we run the code once again, then we can see that this time the items are generated one by one, and the sum is calculated at the end. In summary, stream generators are quite useful because we can use them to emit multiple values over time inside a single function. Stream generators are also called asynchronous generators, and just so you know, in Dart we can also have synchronous generators. So using this same example, here we could add a synchronous generator as a function that returns an iterable of type int. We could call this count and give it an integer argument, and here we would have to type sync star, and then inside the function body we could add the for loop to count from 1 to n. And then we can also yield I like this. And if I comment out these two lines for a second, you can see that these two functions look very similar to each other. And the primary difference is that one is an asynchronous generator and the other one is a synchronous generator, but the syntax is almost identical. So keep in mind that iterables and streams have many things in common because they can be iterated over with a for loop, they can be created using generator functions, and they share many methods that you can use to manipulate or transform their values. But they have one fundamental difference, and that is that iterables are synchronous and streams are asynchronous. Before we continue, I'd like to say that we will see a real-world application of stream generators in one of the upcoming practical projects. But for now, it's good for you to know that stream generators exist and how they work. Okay, so let's continue on the next lesson. In this exercise, we are going to revisit the FizzBuzz algorithm. So, given the following function that implements the FizzBuzz algorithm, convert this to a stream generator by replacing all the print statements with the yield keyword, so that each value is added as a string. To make things fun, introduce a delay of 500 milliseconds inside the for loop, using duration of milliseconds 500. And in the main method, iterate through all the values in the stream and print them. As a reminder, you can find the starter code for this exercise on GitHub. So try to solve this by yourself and then I'll show you the solution. Okay, so let's do this. First of all, we want to change the return type of this function to be a stream of type string. Then we can add async star because this will be a generator. And inside the function body, we can replace all the print statements with yield statements. And the last one should be yield with $i inside a string literal, because this stream should only emit string values. Also, we said that we wanted a 500 millisecond delay between each stream event. So inside the loop, we can add await future.delayed with duration and 500 milliseconds as an argument. And finally, I think we could rename this method to async FizzBuzz, since it is now an asynchronous generator. And now we can test this out. So over here we can add an asynchronous main method using a future return type and the async keyword. And then we can declare a final stream equals async FizzBuzz. And then we can use an await for loop where we iterate on all the values inside the stream. And inside it, we can just print value like this. And if we open the debug console and we run the program, we can see that all the values are printed every 500 milliseconds according to the FizzBuzz algorithm. So this completes our exercise about stream generators. Once again, we will see a practical application of stream generators in one of the upcoming projects. So let's continue on the next lesson. In this lesson, we are going to learn about the various factory constructors that we can use to create streams. And as we have seen previously, we can create a stream with stream.fromIterable. But we also have all these other constructors, so let's see how to use them. And to do that, we can create a new file called streams2.dart, and here we can add the usual void main method. And as we already know, we can create a stream from an iterable by typing stream.fromIterable, and we can pass a list literal like this. We can use stream.value to create a stream that contains only a single value, for example 10. We can use stream.error to create a stream that contains an error. For example, we could add an exception that says something went wrong. So just like a future can complete with an error, a stream can emit an error alongside regular values. If we want to create an empty stream, we can type stream.empty, and we may see how this is useful later on. If we want, we can create a stream from a future. For example, to create a stream that emits only one value after a delay, we could type stream.fromFuture, and as an argument, we can pass future.delayed with a duration of 1 second, and we can use the anonymous function to return a value. And finally, we can create a stream that emits events periodically by typing stream.periodic, and we can pass a duration argument of 1 second and an anonymous function that gives us an index that starts from 0 and increments at each event. So we could use this to return index if we want to create a stream that emits all the integer numbers starting from 0 every second. And in addition to these, there are also other ways of creating streams, which I'm not going to cover because they are not often used in practice. In fact, for now, I just wanted to show you the most useful stream constructors so that you know that they exist and you can use them if needed. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about the various methods that we can use to process or modify the values of a stream. And just to give you a full overview of all the methods that are available, you can head over to this page about streams on the official Dart website, and then on the right hand side menu, you can choose this section about methods that process a stream. And as you can see, a lot of these methods have the same name as the ones that we have explored when we talked about the functional operators that we can use with collections. For example, we can read the first item of a stream or check if the stream is empty. Or we can use the first_where method to get the first value of a stream that matches a certain condition. And as you can see, all these methods return a future because we have to remember that we are dealing with asynchronous data that is produced over time. And in addition to these methods, we also have methods that modify a stream. And here we can find some familiar methods such as map and where. So let's try to use some of these methods and better understand how they work. So let's comment out all these lines from the previous lesson, and we can assign this stream from iterable to a final stream variable. And as a first example, we can type final value equals await stream.first. And in order to use await, we need to make our main method async and update the return value. And then we can print value, and if we run this code, we can see that the value is printed. Okay, so let's comment this code and try something else. For example, here we could type stream.forEach, and then we get an anonymous function with an element, and we can use this to print element. And since this is an asynchronous method, it's best to add an await in front of it, just like we write an await for when we iterate on the values of a stream. And if we run this now, we can see that all the values are printed. So let me comment this out. And another method that is used very often is string.map. So if we wanted, here we could type final doubles equal to stream.map, and we get an anonymous function with a value that we can use to return value times 2. And once again, this behaves just like the iterable map method. And if you want, you can chain multiple methods and call .where and use the value to return a condition. For example, value is greater than 3. And here we could try to print doubles, but if we run this, we get an instance of where stream of int, because we can't just print a stream like this. And as we have just seen, a better way of printing a stream is to use for each. So here we can type await doubles dot for each, and if we want, we can just pass the print method directly as an argument, just like we do when we work with iterables. And now we can comment this line, and if we run this code now, we can see that the output is 4 and 6, which are the only doubled values from the original stream that are greater than 3. So this is how we can use the map, where, and for each stream methods. And if you want to get some more practice using streams, you can try to use the various methods that are listed here. And as we can see, most of these methods can be implemented using an await for loop. So as an exercise, you can try to implement some of these stream methods with a for loop. Okay, so let's continue on the next lesson, where I want to point out some problems that you may encounter when you work with streams. In the last lesson, we have explored some of the methods that we can use to manipulate streams. And before we continue, I'd like to point out one thing. And that is that once you have a stream that is created from an iterable or a stream generator, you can only call one out of the various stream methods that are available. To show you what I mean, I can uncomment this line. And if I try to run this code and open the console, I can see that we get an exception that says bad state stream has already been listened to. And this happens because we have called for each on this stream, and then we have called map on the same stream. And in Dart, there are two types of streams, single subscription streams and broadcast streams. And up until now, we have only been working with single subscription streams. And under the hood, all the methods that we have used until now create a stream subscription, which is something that I will cover in some of the upcoming lessons. So for now, what you need to know is that if you have a single subscription stream, then you can only call one of the available methods on it. Otherwise, you will get this error. Okay, so let me comment this line again. And this completes our overview of the basics of asynchronous programming. Now, asynchronous programming in Dart also includes some more advanced topics such as stream controllers, stream subscriptions, isolates, and completers. But for the majority of use cases that you will encounter when writing Flutter apps, there are third-party packages that offer simpler APIs for working with asynchronous data. In any case, you can learn more about these topics by checking these pages in the official Dart documentation. So we can continue on the next section, where we will work on a new practical project. Welcome to this new practical project, where I'll show you how to build a simple app that can fetch weather information using the MetaWeather API. MetaWeather is a simple website that we can use to check the current weather, and it also comes with an API that we can use to make HTTP requests and request weather data in our Flutter or Dart applications. So in this project, we will use this API to build a new command line application. And the way this works is that we can run this on the command line and pass the name of a city, and then the application fetches the data from the MetaWeather API and shows it on the console. And because this data lives on a remote server, we'll have to write some asynchronous code using futures in order to get the data that we need. And under the hood, this is an interesting networking application, and our challenge will be to figure out how to get the data that we want from the MetaWeather API. So here is a summary of what we will learn on this project. We will start with a brief introduction to REST APIs so that we can better understand how a client app can make a request to get some data from the server. Then we will create a new project and set up a simple command line app that can read the name of a city as an argument. Once we have this, we will create a Weather API client class that will hold all the networking code for our project. And we will use the Dart HTTP package to make an API request and get the response data in JSON format. We will also see how to parse the JSON data into a weather model class using a factory constructor. Finally, we will put everything together and add robust error handling to our code so that we can deal gracefully with connection and API errors. So this will be a good opportunity to learn about networking in Dart and get some more practice working with futures and error handling. Okay, so let's get started. Before we start building our weather application, I'd like to give you a brief overview about REST APIs. And to start off, we need to talk about client-server communication. So here we have a client and a server, and you can think of REST as a standardized protocol that the client can use to communicate with the server. The client can make a request by using a certain method to interact with the server. For example, if the client wants to read some data from the server, it can send a GET request. And the meaning of GET is that we only want to read data without modifying any state on the server. The server will then respond with a status code and a payload that contains the data that the client has requested. So if everything went well, the server will respond with a status code of 200. But if the request was invalid or something went wrong, then the server can respond with a 400 or a 500 error. Typically, a 400 error means that the client did something wrong or requested some data that is not accessible, while a 500 status code is reserved for server errors and may indicate that the server is unavailable or there was a timeout. And if the client wants, it can send a POST request along with some data that needs to be saved on the server. And if this operation completes successfully, then the server can respond with a 201 status code to confirm that the data was created. GET and POST are known as HTTP methods. And in addition to these, clients can also use put, patch, and delete. They all work in a similar way, and the client can choose the most appropriate one depending on what it wants to do. In summary, REST is a protocol that is used for client-server communication. The client can send a request to the server by using any of these HTTP methods, and the server can respond with 200, 300, 400, or 500 status codes along with a payload. And I should also mention that the server sends a payload in a specific format, and the most common formats are JSON, HTML, and XML. HTML and XML are typically used when requesting the pages of a website, because they can be used to define how the data should be presented by the browser. Instead, when we build a mobile app, we are interested in just getting the data, and it is the code inside the client that decides how the data should be presented. So let's continue on the next lesson, where we will start building our weather app in Dart. We are now ready to start building our command line app. And just like we have done before, here I have a new project that includes the usual pubspec.yaml file. So you can grab this file from the resources in this lesson if you need to. And then we can run pub get to get the required dependencies. And since we are building a command line app, we can add a new folder called bin. And then inside it, we can add a new file called main.dart. Then we can add a void main method and add a parameter of type list of string and call this arguments. And the first thing that we want to do is to add a defensive check and make sure that we call this with at least one argument. So here we can type if arguments.length is not equal to 1, then we can print the correct syntax, which is dart with a space and then bin/main.dart, another space, and then the name of the city. And if this condition is true, then we should return early. And once we have done this, here we can type final city equals to argument.first, and then we can print the city. And if we open the terminal, we can type dart bin/main.dart, and if we call this with no argument, we can see that the program prints the syntax prompt. But if we call this and pass London as an argument, then the city name is printed. So this is all we need for now, and we can continue on the next lesson. In this lesson, we are going to learn how to use the Dart HTTP package. And as we can see, the documentation describes this package as a composable, feature-based library for making HTTP requests. To install this, we can open the pubspec.yaml file. And here we want to add the HTTP package as a dependency. So let's add a new line here and type HTTP : and then we can use the latest version number, in this case 0.13.1, like this. And then we can save to get the latest packages. And then inside the bin folder, we can add a new file called weather_API_client.dart. So this file will contain all the networking logic that we need for our application. And in fact, we can create a new class, weather_API_client, that will contain all this logic. And before we go any further, let me explain how we can use the MetaWeather API. As we have seen, when we run our command line app, we pass the name of the city for which we want to get the weather data. However, the MetaWeather API server doesn't return weather data directly by city. Instead, we first need to make a location search query to get a location ID that corresponds to our city. And if a location ID is found, then we need to use it to get weather information for that location. This means that if we want to get the weather data for a given city, we need to make not one, but 2 API requests. Each one of these requests is asynchronous, and we need to run them in sequence because we need the result from the first request in order to execute the second one. And we want all this asynchronous code to live inside our Weather API client class so that the rest of the app becomes simpler, as we just need to pass in the city name as an input and we get the weather data as an output. And as we will see at the end of this section, we also need to handle any errors that we may get along the way. So let's get back to VS Code, and here we can add our first request. And I should mention that all API requests should be made to a specific URL that identifies the MetaWeather API. So the first thing that we want to do is to type static const base URL equal to https and then metaweather.com and then /API at the end. So make sure that you don't forget the HTTPS as well as the www and the trailing API at the end. And now that we have this, let's see how we can make our first request. Over here, we can add a new method that returns a future of type int. We're going to call this getLocationID, and this will take a string city as an argument, and we can mark this as a sync as well. Next, we want to create the location URL that we can use to get data from the API. So here we can type final location URL equal to URI.parse, and then inside it we can pass a string with a value of $base URL /location /search / and then a question mark, and then we can type query equal to $city, like this. So make sure that you type this string exactly as I have done here, otherwise your code won't work. And just to be clear, the first part of this string represents the location search endpoint for the MetaWeather API, and the second part begins with a question mark, and we can use it to add a query parameter to tell the server what city we are looking for. And by using this call to URI.parse, we are converting this string literal into a URI object that we will use to make a request with the HTTP package. And by the way, if you are wondering how I know that this is the right URL to use, all you have to do is to visit the API page on the MetaWeather website, and here you can find a list of all the supported endpoints. And as you can see, the location search URL is the same as I have used in my own code. So whenever you want to use a REST API in your own apps, make sure to check the API documentation so that you know which endpoints are supported. And now we are ready to use the HTTP package that we have installed. And if we move over to the installation instructions, we can see that we need to import the HTTP package when we want to use it. So we can copy this line from here, and then we can go back to our project and we can paste it at the top of our file. And as you can see, this import looks a bit different from what we have used before, because it has this as HTTP syntax at the end. So let me show you how to use this. And over here, we can type final location response equals await and then http.get, and we can pass location URL as an argument. So this HTTP identifier that we used here is the same one that we have declared in our import statement. And we can use this syntax to reference all the methods inside the HTTP package with a common identifier name. And just to be clear, we could remove the as HTTP syntax from here and the HTTP dot syntax from here, and this code would work. But since get is such a common word in the English language, using this syntax gives us a way to prefix all the methods inside this package with an identifier that we choose. And this is a common practice that is sometimes used with certain packages. Okay, so let's continue on the next lesson where we will see how to use the response data. The code that we just added tries to get some data from this location URL and awaits for a response. So when this feature completes, then we have the response data that we need. So what should we do with this? Well, first of all, we need to check the status code to make sure that it is 200, because this will tell us if the server sent back a successful response. So here we can type if location response dot status code is not equal to 200, then we can throw an exception, and the message could be error getting location ID for city and then $city. As we will see, since this method can throw an exception, then when we call it, we can use try and catch to handle it. On the other hand, if the status code was 200, then we need to extract the location ID from the response data. And to do this, we can type final location JSON equals JSON decode, and then as an argument, we can pass location response dot body. And in order to use this JSON decode function, we need to import the Dart convert library. And when we do this, we can see that it's added at the top. So what this function does is to take the response body, which is a string, and convert it to a Dart object that we can use to retrieve the data we need. So what does this data look like? Well, an easy way to find out is to print location JSON. And for now, we can add some temporary code and return 0 so that the compiler is happy. And then we can get back to our main method. And over here, we can remove this print statement. And then we can create an API client by typing final API equals weather API client. And we need to remember to import this from our other file. And now we can call API.getLocationID and pass city as an argument. Okay, so let's save this and try this out. And if we run this on the terminal, we can see that we get a response that looks like this. First of all, we have a pair of square brackets, meaning that we get a list of results. And inside it, we have a map of key value pairs containing the title, location type, some unique ID, as well as the lat long for this location. And the location ID that we want is the value that corresponds to this key. So let's figure out how to extract this location ID from the JSON response. So let's get back to our API client class. And since this is a list that contains one value, here we can type as list to cast this expression to a list object. Then we can remove this temporary code, and instead we can type return location JSON dot first, and then we can use a subscript operator and use WOEID as the key. And the way this works is that by typing dot first, we get the first item in this list. And because this is a map of values, then we can use the subscript operator to access value by key. And just to be explicit, we can also cast this entire expression to be an int, since this is the return type of our future. And now we can save this and get back to our main method. And here we can type final location ID equals await. And if we want to use await, we also need to add a sync to the main method and change the return type to future void. And then we can print the location ID. And after we save, we can open the terminal. And if we run our program again, we can see that after a small delay, it prints the location ID that corresponds to our city. Okay, so let's continue on the next lesson. Now that we have this method to get a location ID for a given city, we can create a new method that takes a location ID as an argument and returns the weather data for that location. So let's see how to do that. Over here, we can add a new method that returns a future of type weather. We can call this fetch weather and give it an int location ID argument. And we can make this method async like this. And as we can see, here we get an error because weather is not a type that we have defined. So for now, we're just going to implement this method, and then I'll show you how to create a weather class that will represent our weather data. So over here, we can add a final weather URL equal to URI.parse, and then we need to specify a string, which will be $base URL /location /location ID. And then we can type final weather response equal to await http.get with weather URL, like this. And just like we had done in the previous method, here we should check the status code and type if weather response.status code is not equal to 200, then we should throw an exception, and the message could be error getting weather for location and then $location ID. Finally, we can type print weather response dot body so that we can check on the console what this response looks like. And then we can add final weather JSON equals JSON decode with weather response dot body. And once we have this, we can return weather dot from JSON with weather JSON. So this completes the code that we need in this method. But of course, I haven't defined the weather class just yet. So let's do that. And inside the bin folder, we can add a new file called weather.dart. And inside it, we can create a class weather like this. But right now, we still don't know what properties we should add to this class. And before we work this out, we need to see what the API response data looks like. So for now, I propose that we add a factory constructor called weather.fromJSON, which takes a map argument with keys of type string and values of type object ? because the values inside the map are always nullable. And then we can call this JSON. And then inside the constructor body, we can throw an unimplemented error. And this is just temporary code because we still need to work out what data we need in this class. So this class doesn't do much at this stage, but if we go back to our weather API client, we can now fix this code by importing weather.dart. And as we can see, we now have this import at the top of the file. And now we have everything we need to get the location ID and fetch the weather for that location. And because we have two separate methods to do this, we could call both of them in sequence inside our main file. But instead, I suggest that we create a new method that does this for us inside this API client. So here we can add a new method that returns a future of type weather, and we can call this getWeather. And this time we're going to pass a string city as an argument, and we can make this method async. And then inside the body, we can add final location ID equals await get location ID with city as an argument. And then we can return fetch weather with location ID. And now that we have this method, we can save this file and then we can call it from the main file. So over here, we can remove these two lines and we can replace them with final weather equals await API.getWeather, passing the city as an argument. And once we run this code, we'll be able to see the JSON data that we get from the API response. So let's continue on the next lesson. We are now ready to test our code and get weather JSON data from the MetaWeather API. So let's open the terminal and we can run our program by passing London as a city. And once we get a response, we can see that we have an unhandled exception of type unimplemented error. And that's because we are throwing this error inside the factory constructor of the weather class. And we will fix this shortly, but for now I want to show you that we also get all this JSON data which contains many different parameters. And this is quite hard to read because it's not formatted nicely. So what we're going to do is to copy all this JSON response data from the opening curly brace to the closing curly brace. And then we can go on one of any number of websites that we can use to format JSON data. For example, here I'm on jsonformatter.org, and if I want, I can paste all my JSON data in here, and then I can click on this button that says Make Pretty, and on the right side, I get a human readable version of the same JSON. And as we can see, the output is a map because it starts with a curly brace, and this contains a key called consolidated weather, and the corresponding value is a list of maps. And each one of these maps contains the weather forecast for one of the upcoming days. So if we are interested in the weather for today, then we need to read the data from the first item in this list. To do this, we can get back to VS Code, and here we can close the terminal and get back to the weather API client file. And here we can modify this code and type final consolidated weather equals to weather JSON, and we can use the subscript operator and use consolidated underscore weather as the key. And we can add as list at the end because this list will contain the weather forecast for all the upcoming days. And since we only want the weather for today, we can change this argument to consolidated weather of index 0. Next, we can remove this print statement, and our next goal is to implement this factory constructor. For now, let's add a print JSON line so that we can see the JSON data for today. And if we open the terminal and run the program again, then this time we get the same exception as before, but if we scroll up, we can see that the console log only shows the weather data for today. So let's work out which ones of these parameters we are interested in. For sure, we would like to show the current temperature, which is stored inside this key value pair. And maybe we could also show the minimum and maximum temperatures for the day. And I think it would also be nice to show the current weather state. For example, here we see heavy rain. So our next step is to create some member variables for the parameters that we want to show, and then we can complete our factory constructor. So let's start by adding a final string weather state and a final double min temp and a final double max temp and a final double temp. Then we need to add a constructor that we can use to initialize these variables. So we can take this constructor and move it to the top. And then we want to add some curly braces so that we can use this constructor with named arguments. Then we can add a comma after the last argument and save this file to reformat our code. And because we are using null safety, we need to make all these arguments required. And we can also make this a const constructor. And now we are ready to implement the factory constructor so that we can create a weather object from this JSON argument. And this is quite easy to do because here we can remove the entire method body, and instead we can use the arrow notation to return a weather object with a weather state of JSON and weather state name as the subscript, and we can cast this as a string. So note how this matches exactly the key that we get in the response data. And then we can add the other argument. So here we can add min temp equal to JSON with min temp as the subscript, and we can cast this as a double. And we can also add the max temp to be JSON of max temp as double. And finally, we can add temp to be JSON of the temp as double as well. So make sure that these subscripts match exactly the keys that we get in the response data. Otherwise, your code won't work. And now that we have this, we can go back to the main method. And here we can add a print weather statement. But if we try to run this code now, we see that we get an instance of weather. And that's because we haven't implemented the toString method for the weather class. So let's fix this, and here we can add override and then string to string, and then we can use the arrow notation, and this time we're going to use a multi-line string literal so that we can easily print all these values in different lines. And inside here we can add current temp, and then we can use string interpolation to print temp.toString as fixed with 0 decimal places, and we can add degrees Celsius at the end. Then we can add the condition to be weather state, and then we can add the daily min to be min temp.toString as fixed with 0 degrees Celsius, and daily max to also be max temp to string as fixed with degrees Celsius. And now our weather app should be working as intended. So we can save this file, and if we run our program once again, then this time we can see that we get the weather information nicely formatted. In summary, in this lesson we have seen how we can convert a map of key value pairs representing some JSON data into a strongly typed immutable model class. And we have used a factory constructor to parse the JSON data. This is considered best practice when working with JSON in Dart, and we should always convert JSON data into a model class like this as soon as we receive it from our API, because that gives us all the advantages of type safety and immutability in Dart. Before we complete this project, there are still some important changes that we need to make to our program. So let's continue on the next lesson, where we will talk about error handling. Our weather app is now working as intended when everything goes well. That is, when we type a valid city and the MetaWeather API returns valid response data and we have a stable internet connection. But if any of these conditions is not true, then we will get an error, and it is our job to handle errors gracefully. So in this lesson, we will add some error handling code that will make our application more robust. And just as proof that what we have now is not adequate, we can try to run our program passing a city name that doesn't exist. And as you can see, we get an exception which is not very user-friendly. And if we inspect this stack trace, we can see exactly where things went wrong. So the way we should read this stack trace is that the program was interrupted by an unhandled exception which took place inside a call to list.first. And this call was made inside the getLocationID method in our Weather API client class. And this in turn was called by the getWeather method, and this in turn was called by our main method. And this happens on line 10, which is where we get the weather for the current city. So if we want to fix our code, we need to locate the line of code inside our project that is closest to the top of the stack trace. So this is the code that we want, and if we hover on this link, we can command click or control click to reveal the code where the error took place. And as we can see, here we are calling location.json.first on a list object. But what happens if the city argument that we have passed is not found? Does the API respond with a 200 status code or not? And if it does give us a 200 status code, what does this list of results look like? Presumably, if a location ID cannot be found, then this list will be empty. So rather than letting an exception be raised when we call .first on an empty list, I think it's best to add a check that says if location.json.isEmpty, then we can throw an exception that says no location found for $city. And now that we made this change, we can run our code again. And this time we can see that the output says exception, no location found for this city name. And this is much clearer than the exception that we had before. But we still need to handle this exception so that we don't end up with this whole stack trace on the console. To do that, we can go back to the main method, and here we can add a try block around these two lines, and then we can catch E, and inside the catch body we can print E. And now we can save and run the program again. And as we can see, this time just a single error line is printed rather than the entire stack trace. So this looks better, but we are not done just yet. In fact, if we go back to the Weather API client, we can see that down here we are trying to read the first item from this consolidated weather list without checking if the list is not empty. So here I suggest that we also add a check that says if consolidated weather.isEmpty, then we should throw an exception that says weather data not available for location ID and then $location ID. Okay, so this is better because we now check if we have the response data before trying to read it. And whenever something goes wrong, we throw an exception. However, exception is the base class for all exceptions, and since this is a Weather API client class, I think it would be better if we had a specialized exception class that we can use to handle errors when we run any of this code. So what I propose we do is to create a class Weather API exception which implements the exception base class, and inside the class body we can add a final string message. And then we can add a const constructor called Weather API exception, and this can take this .message as an argument. And now that we have this exception type, we can use it every time we want to throw an exception inside this class. Like this. Then we can save this file and get back to our main.dart. And here we can update this code and say on Weather API exception catch E. And then we can print e.message inside the catch block. And this makes it explicit that we are only catching exceptions of this type. Okay, so this is much better, but our job is not done yet because we haven't considered what happens if we run this program when we are offline. To show you what I mean, here I can disable my internet connection, and if I run the program again, I can see that I get a socket exception saying that the host lookup has failed for metaweather.com. So it is also a good idea to handle this kind of exception. And to do that, here we can add on socket exception. And in order to use this, we need to import Dart.io. And then we can type catch and use an underscore as a placeholder to indicate that we won't use this argument. And inside the catch block, we can print could not fetch data, check your connection. And now we can save and run again. And this time we can see that this message is displayed. And finally, it might be safe to add one last catch statement, and this will act as a fallback that catches all the exceptions other than socket exception and weather API exception. And now that we added this, our program is complete because it handles all possible failure scenarios that we can encounter when we make this API call. Okay, so it's time to do a wrap up. And the bottom line of this lesson is that if you want to write production-ready code, you need to think about all possible cases where things may go wrong. And you can create your own exception classes to carry more meaningful information about failure conditions in your code. So remember that your job as a software engineer is not to write code that kind of works. Your job is to write code that never fails, or at least do your best to consider all possible failure cases. To do this, you should add robust error handling to your code and write automated tests that give you confidence that your code does what you think it does. Writing tests is a broad topic that we are not going to cover in this section, but you should know that it is important. And it is also important that you know how to read a stack trace when something goes wrong, so that you can diagnose and fix things by yourself. And I hope that this lesson has given you some guidance on this. Okay, so we have now reached the end of this section, and I hope that this project has given you a real feel for how to use features to write networking code in Dart, and the importance of handling exceptions in your own code. And while this was just a command line application, we have taken great care in designing things so that all the networking code lives inside a weather API client class that is easy to use because you can get the weather with just a single method call. So if you were to build a weather app using Flutter, you could easily import this class along with the weather model class and hook it up to your UI. Okay, so let's continue in the next section. You have now reached the end of this course, so congratulations for making it all the way to this point. I hope that all the course content, exercises, and practical projects have helped you become more confident with the Dart language. I will keep this course updated with the latest Dart version, so as you continue in your programming journey, feel free to use this material as a reference. And there is more, because I have a gift for you, which is a great complement to all the video content in this course. So just for you, I'm sharing this free ebook, which is a complete reference to the Dart language. This contains over 150 pages of content, covering all the features of the Dart language, along with some extra materials on good coding principles in Dart. This is a valuable reference that you can use to look things up when you build your own Dart or Flutter apps. And finally, I'd like to say a big thank you for taking this course. And if you've enjoyed the content that we covered so far, please leave a review and tell me which things you liked and which other ones I can improve so that I can make this course even better. So thank you once again and good luck with your programming journey.